circuit. Before we begin, there are two things that are always true for parallel circuits. First, there are multiple loops in a parallel circuit. Multiple loops implies multiple currents. And what this means is that the current in each of the resistors added together is equal to the current from the battery. Also, there is only one voltage in a parallel circuit. It's the voltage of the battery, and all the resistors have this voltage. The next step is to draw and label a schematic. Here I've shown the battery, the current from the battery, and two resistors hooked up in parallel. I'm going to use the following values to analyze this circuit. The next step is to find the equivalent resistance. For a parallel circuit, this is equal to the sum of the reciprocals of the resistance. Here I've shown the calculation and the result of 8 ohms. The calculation is most easily done using your calculator and the x to the -1 key. Notice that the equivalent resistance is less than either one of the two resistors. This should always be the case in a parallel circuit. The reason we find the equivalent resistance is because using the equivalent resistance, we can find the current from the battery, I sub B. The current from the battery is equal to the voltage on the battery divided by the equivalent resistance, in this case, 1.5 amps. The next step is to calculate the current through each of the resistors. The current through a resistor is equal to the voltage on the resistor, which is always the battery voltage in a parallel circuit, divided by the resistance. Here I've done that for the two resistors given. The next step is to calculate the power delivered from the battery and used by each of the resistors. Power is V times I. The power from the battery is the voltage on the battery times the current from the battery, in this case 18 watts. The power used by each resistor is the voltage on the resistor times the current through each resistor, which we previously worked out. Here I show the two powers used by the two resistors. From here, we can build a complete table for the circuit. I've listed the resistance, the voltage, the amps, and the power. With this table, it's easy to check if you've done the analysis correctly. Let's remember the two truths that we began with. The first is that the current from the battery is equal to the sum of the current through the resistors. Notice that the sum of the current through the resistors does in fact equal the current from the battery. Second, in a parallel circuit, there is only one voltage. And yes, we have the same voltage on the battery and all the resistors. The final check, which is true for all circuits and is based on conservation of energy, is that the power from the battery must equal the power used up on the resistors. And sure enough, you can see that the power used on our resistors adds up to the power from the battery.